Forget cloud dependency for large language models. Running Llama 3 locally requires specific hardware validation before deployment. Your system must possess a minimum of 16 gigabytes of unified memory for the 8 billion parameter model, although 32 gigabytes is recommended for stable operation under load. Crucially, verify CUDA compatibility if using NVIDIA, or ROCm for AMD, ensuring driver version 535 or higher is installed. Ollama leverages these frameworks for GPU offloading, drastically reducing inference latency from seconds to milliseconds. If your setup relies solely on CPU, expect token generation rates below 5 tokens per second, rendering it impractical for real-time application development. Confirming these prerequisites prevents deployment failure and ensures the necessary performance baseline for system integration. Install Ollama directly using the official one-line script for Linux or Mac OS. curl-fssl https://ollama.com/install.sh pipe shesh. For Windows, download the executable and ensure it is added to the system path, allowing command line access. After installation, verify the service status. Execute Ollama-version to confirm the binary is accessible and running as a background service on port 11434. This port is the default REST application programming interface endpoint. If the service fails to start, check for port conflicts, particularly with other local web servers or container runtimes. Successful installation means the local model registry is initialized and ready for model pulling operations. Initiate the model download using the command ollama pull llama 3 8b. This command retrieves the quantized 8-bit version optimized for local execution. Monitor the console output to confirm the layer hashes match the expected manifest, ensuring data integrity during transfer. The total download size is approximately 4.7 gigabytes. Once complete, execute Ollama run llama 3 8b hello world to perform a zero-shot test inference. This verifies the model is correctly mapped into memory and the kernel is functioning. If the model fails to load, check the system logs for memory allocation errors, indicating insufficient available random access memory or incorrect GPU mapping. The command line interface is useful for rapid prototyping and prompt validation. To exit the interactive session, use Ctrl+D. When prompting for system analysis, structure your input clearly. For example, request a specific output format. Generate a Python function to parse Apache logs, returning a JSON object with fields timestamp, status code, and request path. Avoid vague instructions. Use triple backticks to delineate code blocks within your prompt if the model is expected to process existing code. This improves tokenization accuracy. Remember, the command line interface session maintains context history, allowing for multi-turn conversations, which is essential for iterative debugging or refinement tasks. For application integration, the Ollama service must be accessible via its REST application programming interface. By default, it binds to 127.0.0.1. To expose it to the local network or containerized applications, set the Ollama host environment variable before starting the service. Set Ollama host equals 0.0.0.0/11434 to bind to all interfaces. Restart the Ollama service immediately after modifying this variable. Verify accessibility by executing a simple curl request against the generate endpoint. curl-x post https://localhost:1143/API/generate. A successful response confirms the endpoint is active and ready to receive structured JSON payloads from your application layer.
Application development requires a robust client library. While dedicated Ollama libraries exist, using the standard Python requests library provides maximum control over the HTTP communication layer. Ensure your environment uses Python 3.10 or newer. Install the necessary dependency, pip install requests. Define a base uniform resource locator variable pointing to your exposed Ollama host, typically http://localhost:11434. This setup minimizes external dependencies and allows direct manipulation of the request headers and body, which is crucial for handling streaming responses and custom authentication if implemented later. The generate endpoint requires a specific JSON structure. The minimum required fields are model set to llama 3 8b and prompt containing the input text. For system analysis tasks, always include the stream parameter set to false initially for synchronous testing or true for real-time user experience. Define the options object to control inference parameters. For instance, setting temperature to 0.1 ensures deterministic factual responses, ideal for code generation or data extraction, unlike creative tasks. The payload must be serialized correctly using JSON.dumps before being sent as the request body. To provide a low-latency user experience, set the stream parameter to true in the request payload. The application programming interface will return a sequence of JSON objects, each containing a fragment of the generated response. Your client code must iterate over the response object using response.iter_content and decode each chunk. Implement robust error handling for incomplete JSON objects, as network interruptions can truncate the stream. Concatenate the response field from each chunk until the done field is received as true, signaling the end of the generation process. This asynchronous approach prevents application blocking during long inference cycles. Monitor GPU utilization using nvidia-smi or the equivalent tool for your hardware during inference. High utilization, near 95%, indicates the model is fully offloaded. If utilization is low, verify the memory mapping configuration within Ollama. Adjust the context window size using the num-cox option in the request payload. Reducing this value saves video random access memory, but limits the model's memory of previous turns. For persistent performance, ensure the model remains loaded in memory by avoiding system shutdowns or manual unloading, minimizing the initial load time for subsequent requests. Fine-tune generation behavior using advanced parameters within the options object. Set top P to a low value, such as 0.9, to restrict sampling to the most probable tokens, increasing factual accuracy for technical outputs. Implement a repeat penalty of 1.1 or higher to prevent the model from generating repetitive code snippets or boilerplate text, a common issue in system documentation generation. For strict output length control, use num-predict to define the maximum number of tokens generated per request. These precise controls ensure the model output meets the rigorous requirements of system analysts.